Ancient black holes may have survived an era before the Big Bang.
Imagine that some of the oldest black holes in the universe are actually older than the Big Bang itself.
This is what a new study from the University of Portsmouth suggests, proposing a different model for the origin of the cosmos. Instead of beginning with a singular explosion, the universe could have gone through a cosmic bounce, a contraction phase that then reversed direction and began to expand, as we observe today. In this scenario, structures formed before this transition could have survived, functioning as cosmic fossils that carry information from an era prior to the one we know. Professor Enrique Gaztañaga, lead author of the research, explains that the traditional Big Bang model explains very well what we see, such as the cosmic microwave background radiation and the distribution of galaxies. However, it leaves important questions unanswered. What caused the Big Bang? What is dark matter, which is about 5 times more abundant than ordinary matter, and what triggered the rapid initial expansion called inflation? The cosmic bounce theory offers a natural alternative. Instead of reaching a singularity of infinite density where the laws of physics as we know them cease to function, the universe would reach an extremely high, but finite, density. Quantum effects would generate enough pressure to halt the collapse and initiate expansion again, without needing new exotic physics. In this model, some black holes could have formed before the bounce and survived the transition, remaining to this day. Others would have emerged soon after, aided by large density fluctuations that facilitated the collapse of matter. Calculations indicate that compact objects larger than about 90 meters could survive the process.
These ancient black holes would be perfect candidates to explain dark matter. If they exist in sufficient quantity, they could represent a large part or even all of this invisible substance that influences the formation of galaxies. Furthermore, they would help to understand why the James Webb Telescope observed such large and mature structures so early in the young universe, such as the so-called red dots. The model could also explain the initial inflation and the current acceleration of the universe's expansion, attributed to dark energy. To test it, scientists are searching for remnant gravitational waves or subtle signals in the cosmic microwave background radiation that reveal conditions prior to the Big Bang. There is still much work ahead, but if this idea is confirmed, the dark structures that shape galaxies today could be relics of an era that preceded the Big Bang. This perspective elegantly and naturally connects several of the greatest mysteries of cosmology.